So, hello everyone. I hope the translate stream is started. And let's check. Can you hear me? Let's check. Yeah, okay, everything is working. No, I don't need a sound here. Oh, sorry. So, okay. I hope you can see me and hear me, and everything is going fine. Today we are going to code a little bit, and we will check the language called Rust. And we will not go any kind of deep, um, just the overall language syntax, standard library, and we will code a little bit to test what this language can do. And as we mentioned, it will be some kind of TCP chat. I don't really know how it will go because I mostly I almost never did this, and yeah, here Misha, come here. Hello, this is Misha Korneev. We made the Moscow Python together, so he's here to join us. Okay, so I tried Rust before this, but just for a Hello World. So it will be new for me also, and I hope we will be able to make something working today. And let's just take a short look to this language and the site of this. I hope you everybody installed Rust, but if you have no chance to do this, there is a playground. It's available on the site. You can write code there and run it right in your browser. So it will not require any installation on your computer. But of course, it will be executed somewhere in the cloud, so we will not have real access to what's going on. Okay, let's take a brief look on the language syntax. Wait a second, sorry. Yeah, sorry. So the website have a lot of information, and since we are going to do the command line tool today, let's switch right to the command line book. We will skip a little bit of basics, and we'll get to more specific documentation part, but I hope we will understand enough from it and we'll be able to code something. So as you can see, documentation is well structured. There is a even if it's not the first guide you need to walk through in the most cases, project setup is also mentioned here. So we installed Rust, I hope. If not, there is a link to download it to your computer. I did it up front, so I'm going to code right now. So I will use, so as you can see, there is a tool which is provided with the Rust. It's called Cargo. It's Rust package manager and I think utilities services. So we can create the new project just using it. So let's check. Silly cargo new, and since this will be chat, I hope it will be. We will need the server and the client. So okay, let's call it chat server. Oops, sorry. And yeah, created binary application chat server package. Okay, let's check how it affected the project structure. And here we have chat servers, chat server directory, and source code. Source code is just a hello world. And this is the point where I stopped last time. So we can use, oh, sorry, we need to switch to the chat server and use cargo run. This will compile our code and execute it. And yeah, there is a build steps, and here it is, our hello world. So technically it's working, and we have new directory in our project structure. This is a target, debug information. I think there is a lot of technical stuff we don't need to think about. It's collect, and there is an execution file. So I think if we will go to the debug target debug, and we'll call chat server, it will be executed as just an application. So we just made the very, very simple but working application with Rust. But let's take a look on the code which doing this. So we have function main, and syntax quite simple, fn. It's not the unique syntax. It's fn keyword is used for functions in a couple of languages. So main as a function to execute when we are running our program. So later, when we will work a little bit on composition of functions, this function will receive will contain only I don't know only calls for other functions, and that's it. But since we are only trying, we will not work on any design right now. We will just try to code something. Okay, so I hope you also were able to create the cargo file. You use cargo to create the project and to obtain the hello world. Let's move forward. Next step, and next step is describing how programs in command line is usually works. So we are using arguments. And how we can get the arguments, it also looks quite usual. Of course, syntax is different from other languages, but what we are doing here, there is a standard library, there is environment library inside, or model, I don't know the structure yet, and args function. So it will return us an iterator. So we will see something. Let's try. And interesting thing here, we can see how the variables are defined in Rust, and the keyword is let. So I think it's also not a very surprising thing. Let's just do some experiments since we are not having something. So by the way, the one thing I already know about the Rust is that print line is not actually a function. It's so-called macros. And to call macros, we need to use this sign. God damn it, I forgot the word. Okay, anyway, not a big deal. So we can have let args be equal to, it should be an a list, or this is an iterator as mentioned in the documentation. So what iterator is? Let's go and take a brief look. Okay, it's a trait executable iterator, and it have type. So iterators are typed, unlike in dynamic languages like Python and Java. Looks like iterator can contain only a single type of only variables of single type, and mute. It looks like it's mutable variables, but okay, we will get there soon. What we can do with the iterator, I will not check how we can create it by ourselves, but what it have. So it's new, it's next. Okay, so we can call next. Oh, and we can use for in. I think for most of the developers in PHP, in JavaScript, this is in Python, it's also very similar syntax for loops. So let's try to see what we will have. Oh, sorry, yeah. Okay, so let's try to see. Let's get back and let's try to iterate through for arg and args. I think we need to make the font a little bit. Sorry, I can make it bigger. Oh, okay, yeah. Okay, I think it will be more comfortable to see. Oh, a little bit too far. Okay, for args and arg. Yeah, as you can see, I have this Python code reflexes. But let's try to see what is each arg. Okay, another comment I know. Oops, sorry. I also trying to increase the text size, but doesn't look like I can do this here. Okay, cargo check. this, so as you can see, if we want to um, print variables directly, print ln and our Rust asks us to use such kind of syntax. I think it's safe literals like in Python, but without any extra syntax. Maybe just because the println macros created like this, but not like the any kind of syntax level thing. And I think this is just to be sure that arg can be any type. So variable we want to print can be any type, and this will be the safe way to convert it to the strings. Okay, let's run cargo check again. Okay, it's cool. Cargo run, but yeah, it will do. Oh, yeah, of course, first argument is always the comment we are just using. So target, and then bug, chat server, and I don't know, some arguments. And here we go. We have all of them, and it's already not bad. This means that we can start our chat application. Yeah, macros. I can see the questions. Sorry, I maybe will delay a little bit answering the questions because I can't look into all screens in one moment. So talking about macros. Macros is in the most languages which contain macros. It's a special construction which allows to create code which will on the compilation state will be replaced with another code. So for example, with this print ln, let's get learn and let's just check the print ln. I think it should be there. Hey, documentation. Oh, we are already in documentation, sorry. So let's search for println. Yes, here it is. So as you can see, this is a macros, and it contains some code inside for the different with the different behavior. This is when we are calling when we are using this macros with no arguments. Here, if we are doing this with arguments, and it's not described here what exactly happening inside, but I think there is a quite complex logic there. We also, if we are very interested, we can go to the source code, but I don't want to do this right now. And oh, it's a good tip here. We can use format macros if we want to format our output somehow. But in fact, inside this println macro, Rust will just use IO library and write something in standard output channel. So there are some examples. But what the difference with the function? When we are doing function println, it will be executed as function each time we are actually executing our program. And the macro will replace the code if we are just putting println in our code as a single line. It will be replaced during compilation to the full source described in as a macros body. So as you can see, macros body is quite huge. There is a lot of logic here. Um, so if we will, and it will optimize the process. So less functions, faster execution. That's why macros are very useful thing in case we are doing, oh, sorry, in case we are doing optimized application for fast execution. Um, but the problem of the macros, why everything is not just macros, why we use functions, that it's quite harder to debug because there is no code line where we can have error just because our source code doesn't contain all the lines that which will be used in runtime. So I hope it answered your question, and let's get back to our attempts to write something for client. And we are at the step of parsing arguments. And okay, so structures. What can we have using structure? Structure is a construction which allow us to create, to store different data in a same variable with attributes. But for example, this CLI structure have two attributes. One is named pattern and have a type string. And the second is path, and it's have the special type from standard library. So this is just a declaration. There is no data here. There is nothing that can be used really, but we can create our variable with this type, this structure type with setting all exact values. So in this example, it will be the args args variable with pattern as I don't know, first and yeah, first and second arguments from our iterator of arguments in which we're using to call when we're running our application. So let's keep it for a while. We don't need this CLI, but I hope we will find usage for this. And this look like okay. Clap. There is like in the most modern languages, there is a not only standard library, there are a lot of different external libraries we can use. So, for example, clap, it looks like it is syntax sugar for having for using and creating command line applications. But I think we will not use it today, just to use the very, very basic of the language itself with the very simple structures and applications. But yeah, it looks very useful because where we had this list of strings with the code, we can just use a single line args parse from the clap library. But okay, let's move somewhere forward. So what else do we now we can show messages, show text to the user. It's already a good step to our chat, but I think it's more related to the client, but not to server. So let's think what we need also. Since we are working on a server, let's think about the TCP sockets. As you remember last time, if you watched the recording or attended meeting code, last time we created the very basic HTTP server and talked a lot about network level and used raw TCP sockets. We will do the same here. Let's take a look. Okay, very fast search in official documentation shows us that standard library have this TCP stream. It's connection between two sockets, and TCP listener. It's in fact the server itself. So object that can provide us with the possibility to accept connections. So what do we have? Okay, so as you mentioned last time when we watched the code, all of the code was using this std, then env, so full path to the function, but it looks like we don't necessarily will do this all the time because Rust have this use keyword which well, import or making some parts of the libraries available, classes, functions available using their direct names, but not the full path. So useful. Okay. And this line will create the open the socket on address and port, just the same we did in HTTP server. And later we will be able to accept connections. What is this sign? I'm not very sure. Let's go to the playground, official playground, and check it online. Wait a second. Playground. Okay. A equal 1. Let B equal A. Print ln B. I don't know what I'm doing. I'm just okay. With a try. Okay. So looks like this operator question mark is some kind of try except or try catch from another languages. Let's get back to the documentation. Yeah, we want TCP. TCP listener. Okay, let's try to cut something very, very simple again. Let's switch let's switch to code, and yeah, okay. We are not going to use this right now. If we will need it, we will write it again. Use std net and TCP list. I'm not sure about the syntax, so we are switching back to the communication. TCP listener from yeah, okay, and TCP stream. Okay, yeah, it's a type. Okay, TCP, and there is also to listener TCP stream. Okay, and let server equal TCP listener bind. Yeah, of course we will use localhost, I don't know, 8080. But let's just try to print and see what's happening. Cargo run. Compile due to the two. Okay, so it's unused import. It's okay. It's in the function that returns the result of options or another type of implementation of. Interesting. What I'm doing wrong. Let's check the documentation again. We need to return awk. Okay, awk. Return. Okay. Oh, sorry, it's typo. Okay, okay. Cargo check. No. Expected. Something is not right. And again, let's go to documentation. There is no. Okay, I'm also doing okay. And let's check. No, expected. Oh, of course. Our main function is not returning anything because we didn't declare the returning type. And this means that it's void, and void doesn't return what it expected, and we can use question mark in void functions. So let's check how the syntax for, yeah, standard input output result. Okay, so this reflects that we later, now we will show the sign, the variable type that we will return. So it's a result. I'm not sure about the syntax yet. Okay, yeah. So it's result with no arguments. And then we can use this awk. Let's check our code again, and or error. Interesting. One generic argument. Yeah, we don't need to use return name. That's unusual. Yanon takes two arguments. TCP stream, it's okay, warning. Yeah, sorry, misusage of syntax. So this is a familiar for Python JavaScript developers, but this is not how methods inside the object call, so we need to use this double column. Okay, this is the first issue. This is unused. Okay. I will remove it for a moment. This enum takes two generic arguments when one generic argument was supplied. And that's interesting. Let's compare this to code that we example we're using. So, and very interesting. Nothing. If we will run it, it will open the playground. Wait a second. IO. Oh, I think I understood the issue. Yeah. So it's definitely not just. Oh. I used the result, but it's std input output result. So it's a looks like it's a different class, just result, not related to input output. Let's do the check again. Okay. Yeah. So this just says that unfortunately we can't just print server as just a string. So let's go further. For stream in server stream, I think. Let's check. No, listener incoming. Okay, and println stream. I don't know if it will work, but maybe. Let's check. So to invoke the oh yeah, of course. I'm not a function. Yeah, of course it's not a function. For I'm doing something wrong again. Why? Use of undeclared create a models. Oh, yeah. Thank you, Misha. There was a dot in incoming, and no. Use of undeclared create or model server. Oh, okay. So double column is used for models. Okay, this is a good point. So we need to use a dot when we're using methods or arguments, and double column if this is a model and this is a method inside a model or function. Okay, not bad. Result method not found. And okay, let's go to the documentation and check how this TCP stream is working, because we will use it. And so do we have it here? Somewhere. Oh, listen on into incoming. Okay, accept. What do we do? Okay, handle client. There's a declaration of handle client. Okay, let's go back to the documentation and take a TCP stream. Okay, stream connect. So it's connect, write, read. Oh, okay. So we need to say first. We need to to create a named variable mutable with the list of to show the and set two arguments which are beginning of stream reading and the end. So in fact, it's the length of content we want to read. Let's try. So interesting. What is mute? I think my bad. It's that this is mutable variables and mutable types, but so we need to mute. Let's read. Not too much. Okay, check. No. Okay. Method not found in method because I'm trying to stream and server incoming. I'm not sure I'm doing this right. Okay. And get back to the documentation. Always get back to the documentation. Okay. In fact, I'm doing it not very in the right way because I'm just playing around and not following any guide to understand everything, but it's just a little bit more fun for me. So let's continue. Unwrap. Interesting thing, it's a lot of unwrap here. We will need to see what the unwrap is. Coming. HTTP handle connection. So yes, this is handle connection. Handle. Is there any further steps in the documentation? Don't think so. Okay, so it's TCP listener, TCP listener, TCP stream coming, outcoming. Result TCP like functions. Okay. Accept bind incoming stream. So it's a stream. Okay. Let's get back to the stream documentation once again. And let's take a look on the methods. So what connect, peak, no delay. That's the trail implementations. Okay, this is the right implementation. Right, so this is the right function for the different mute self and buff. Okay, so looks like we need to provide the first argument here. But it's look a little bit weird. Mute self, so it's and then buffer. Okay, so let's search for dot write and dot read. We need to set from where we need to read. Okay. Okay, it's not so. This used for as a client. Okay, let's get back a little bit. TCP listener. Okay. Listener incoming. And this will be the TCP stream. TCP stream. Okay. Let's stream handle client stream. This stream is a handle client. Handle client. Accept unwrap. Why it's unwrapping? Let's take a look on what the unwrap is for listener, for example. TCP ls. Interesting. Oh, I think it's, yeah, it's when we're using links. It's return actual value. Okay. So let's go back to net. Let's take a look. TCP listener, provide functionality over the TCP. Okay, we need to set this thing. Listener incoming. Then, okay. So let's. Okay, let's first of all check server. Oh, here we're using this instead of unwrap. Stream read wrap. I don't think we need it mutable. No, and TCP stream. TCP stream. It's very weird. So, okay, so I found this thing. Okay, so we need to unwrap. So this is a link, and we need to get the actual value. And okay, we have something new finally. So, what was our mistake? Our mistake was that server incoming returns not the stream, not the variable that contains TCP stream itself, but it contains a link to TCP stream, and we need to unwrap this link if we want to work with the object itself. So we are getting actual object from the link, and then we can read it. But let's method not found yet. Okay, and found no method found. Read for TCP stream. TCP stream in this scope. So maybe we need to import it here. Read mute self and mute. So looks like we still need to do something in addition to what we are doing. So let's, it's very possible that I'm doing the syntax mistakes here. Okay, let's do this. Okay. No, we don't need it yet. Read not found, type stream listening coming. Okay, so let's unwrap, let's create buffer call mutable list from the length on something wrong with this mute. Yeah, okay, so it's mutable, but I'm doing something. Oh, yeah, I got it. I need to set the mutable state of the buffer before the name. Okay, so what do we have here? We have this buffer. We have a stream and stream read to the buffer. So what I think it should be like this. This means that let text equal unwrap, and let's try to print it. Check. Okay. Interesting. We're still have the same old issue. Okay. Let's unwrap it instead of method is not found. Stream read, and we need to. This is the way. This is the way. Okay, so that's better. We finally got what we wanted. So stream read accepts link to the variable, mutable variable, and mutate it, but not return the value of reading. So, and then we are unwrapping it just to get the real value. I have a feeling that there is something lazy inside the such kind of functions, and unwrap also will return the actual result. And now we need to convert it to something, and I have a and if we will we'll try to do this. Integer cannot be formatted. Oh, okay, yeah. We want to. Okay. Okay. Oh, I found it. How we need to encode the string. I have to do so. Yeah, I'm cheating here. I have a short using a short cheat list. So we need to translate binary to text, and what the why we had the same old issue. That's the very strange, because we are. So what will happen if we will just code? Interesting. Oh, I'm on rep. And let's try to send it like mutable link. still don't want to do this. Okay. Method read. Still not found. Okay. That doesn't. So it's okay. Be bringing. Okay. Yeah, forget it. So documentation says that we need to use this. Yeah, very funny. So since Rust using threads for extending structures, we need to import them in the scope of our application to change the behavior of TCP listener and the stream. So they really didn't had anything. Okay, let's. So without this line, our TCP listener was and TCP stream structures didn't had the read-write methods. So this, because there was no threads in the scope of our program, we imported it, and now the scope, they modified the behavior of TCP stream, and now they have different methods like read and write because they are not part of original structure. Okay, and let's run. Maybe it's even okay. So it's running. Let's try to send a simple request. I will do it from the separate browser. Just so localhost 8080. And what's happening? Okay, what does it look like? We received all the messages that were sent by our browser. It's a lot of headers here, but it's okay. Cool. This means that our TCP server can accept connection and read the request. Well, not request, incoming information. Yeah, not bad already. Let's then think about our next step. So after we read something, we need to send something back. So let's think what we can. We need to, of course, use write, but what arguments do we have? Let's just hello world in answer, and again, cargo check, no. Okay, so we need to send binary, but not, okay, we can use leading B, so this will be the binary or buffered line. Okay, let's try. Yeah, unused must warn unused. Okay. Unwrap. Let's check again. Yeah, so I was right. Without unwrap, this is the lazy operation. So nothing actually happens until somebody will try to access the result, and unwrap actually access the result. Okay, cargo check. And again, cargo run. So let's send And what's happening? And does anything happens? Oh, of course, we are not trying to. We remove the print so we don't receive the result. Okay, let's think a second about how can we. Okay, let's using Python. Wait a second, please. I will think about the very basic TCP test tool for. Yeah, I think I have an idea. We can try to use the telnet. So what do we have? We have this telnet to the local host port 8080. Funny thing, I don't have telnet. Okay. Why I don't have it? I think. Wait a second. Yeah, I will need to use the brew to install it, and it will take some time, I suppose. It will take more time than I think because I didn't use brew for a while and it's not up to date, I suppose. Okay. We have this thing. Yeah, we have MC. So let's try. Well, MC. So can MC. Yeah. So since we can connect, we can send, and we can receive then an answer. So once again, why we are waiting here? This is just because we have this function here, read, and the socket is in blocking mode. So unless it will read something, and it means that the client will set something, our server will not move forward. So, okay, we're doing this. So yeah, this hello world, and interesting why we have percentage here, but okay. Okay, so in the very, 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 very basic, we can accept and send messages. What should we do to convert it to any kind of chat? First, we need the list of clients. So we need to declare some kind of structure that which will handle all accepted connections. This is the first thing. And the second thing, we will need to be able to iterate through this to send the messages when somebody is sending. But it's one connection at a time. Okay, so what will we? By the way, interesting. Would we need to close the connection, or it closed automatically after doing everything? And what will happen if we will try to run this? So it's blocking. We are trying to connect for the first time and not receiving anything. So it's up, and let's try to connect one more time. And interesting, if we will, yeah. So since we are using single-threaded server, only one connection can be accepted in a single moment of time. So until we will close this connection and handle this connection, we will not be able to handle this connection. Okay, so let's check once again. And here, so nothing happened because we ran it after, and oh, of course, I need to restart the server. So here it is, here it is. Nothing happens. It's reading, returning hello world, and yeah, doing the same, but with a huge delay. But after that, we can't continue to communicate with the stream just because it's ended. So we need to run the threads, different thread for each connection. Okay, let's go to documentation and ask for the thread. Yeah, so, and here it is. We have native threads. Spawn, move. Okay, spawn in a thread. Okay. Okay. Stack size. Interesting. So threads are quite controllable here. We have thread local storage. It's also model provides possibility to use the data only in a thread local environment, so it will make your application thread safety. But okay, what do we want to do? Let's just, oh, I'm not showing, sorry. Yeah, so this is the thread model, and communication between threads can be done through the channels. So different threads can send information to each other using channels. It's good. The simple way to start a thread is just a spawn. Some work here. Okay, let's just copy and paste this thing. And if we want to get the result of this thread, we need to join it. Okay, it looks like all other streams. Okay, so we need new function. Function handle connection. Function will accept TCP stream, TCP stream, and okay. What's connection? No, this is like this. So yeah, sorry, no, we don't need this here. Use as the thread as a kind of here, and this code will go here, and this code will go here. But if we'll do this join thing, it will block the progress until this thread will be executed, but we don't want to stop execution of the thread. Some work here. So we don't want to use the anonymous function. We need to call the handle connection. And we are doing something wrong because of this index error. So let's just take a look. Yeah, of course, there is a syntax error. We need to use the column here. Okay, let's try. So we will not just save it in any kind of ration, and we will send arguments there. And let's get back to TCP. No, we need, yeah, thread. How can we pass arguments to the thread? So, what do we have? Spawn, move, print. It's so using this syntax, we can create anonymous function, and it will just the body of the function here, but we don't want to do this right now. We want to pass arguments there, and I'm not sure how we can do this. Okay. What if we will pass the stream there? Let's check. Okay. Cargo, check. And unused imports. Why they unused? They're not unused. TCP stream. Okay. Spawn required by own. Okay. So let's think function. Let's take a look for more examples if we will find them. Okay. So spawn takes a function and okay. Spawn thread code. Join unwrap channel spawn send hello thread receiver thread. Okay, this is an example how our threads can communicate. This is fine, but not right now. Okay, it's useful, but not what we're expecting to see here. And server. Okay, so okay. Okay, I think I got it. There is no other syntax, so it's always should be here. So what we are going to do is to put the handle connection call right here, and let's take a look what check will say about this. A little bit better, but unused, stream, not enum result. Interesting. Oh. Looks like we need to unwrap it before sending because no, and we are accepting here stream. Okay. stream. Remove this mute. No, because we want mute stream. Okay. Okay, so we can remove this mute because we're unwrapping it. Okay. Okay, so technically everything is working. So let's run. Good. Connection. Hello world. Okay, let's restart it. So we are doing first connection. As you remember, when we are trying to connect the second time, it didn't work yet, but now it's working. And we still can use the first one. Okay, now our server can handle multiple connections. Let's think about the possibility to send information to each of them. So let's switch back to documentation, and I think we saw interesting thing here with about the communication between threads using channels. Let's check channels. What this is a simple channel have incoming and outgoing and can send it between different threads. For example, we have input output, and we can first thread. So we have in this example we have multiple threads, 10 threads spawned, and for each thread we are cloning our TX. TX is a transmission, so it's the object to send messages, and RX is object for receive messages, and we can send it, and later we can receive it in the main thread or in other thread. Okay, not bad. Let's create struct clients. No, it's struct server with clients of what type will we use here? I think we will use thread, but what type thread does have? So I think it's thread. Okay, let's try. So we are let thread. Oh, it's not a single thread. We need to understand how to create a list of threads. I think it's a kind of list. It's not the type. Oh, okay. In return types, list. No. Okay, I think it could be a vector. Yeah, it's a vector. Okay, a vector new. So we are a continuous global array type with the heap allocated contents. Okay, so this is a syntax vec new. Okay. Yeah, so this is the syntax. Okay. Vec new. Let's move forward. Okay, coding. Clients. Vec new. Okay. Do we need to import this by the way? Not doesn't look like this. And there is a vec macros. Interesting. Okay, but next time. Let clients, and okay, here we can set the type. Type is vector of threads. We have something like this, maybe. Let's stop our server and run the check. No, it's not a thread because it's oh, sorry. Let's check the documentation once again, and we have the thread, native threads, but what type? What type is it? Thread builder, thread. Well, it's thread type, so we have this. But okay, why? Because I think std red thread. Yeah, cool. Okay, vector. So after that, we have, yeah, so we use this like this, and now we need to let thread equal thread span. Oh, it will be shadowing. Client thread equal, and let call. Okay, let's rename this to listener, and server will be server new. Interesting. There is no such function, so we need to write an implementation if we need to. So I saw the code like this, so this is an implementation, but I I don't remember what's next. So let's switch to the documentation again and take a fast look at any kind of examples. So primitive types. No, we need structures. Struct. Okay, let's check this. Struct. Keyword. Yeah. So public field. Oh, it's a private field, by the way. Interesting. Full example. It's exact implementation. If we want new, it will. Oh, so new value. Okay, let's not spend time on creating a new and just create server with clients equal vec. Something is not the way I expect this to happen. Where did we saw this? Oh, yeah, vector. Okay. Of course, it's just not because of. So we created empty, but how can we append push? Okay, let's try. Server push client thread for server and client in server thread. Oh, server clients Interesting. Will it unwrap? Okay. Oops, sorry, again. No, not a good day today to. So thread cannot be formatted. Okay, thread thread. Does the thread have some kind of ID or something? Okay. Thread name. Thread builder. Okay, it's not the thing we don't want to. Channels. Thread spawn function. It returns the function. Yeah, thread object. So thread object. What name? NID. Yeah. Okay. So it contains ID. So we can try to countering. Okay. ID is a method. Okay. Not neither formatted to the full formatter, but why? Okay. Name. Does it have name? Options. Okay. So let's get back to documentation once again. Thread name. So methods name. How we can use thread name? Builder new spawn or thread ID. Self thread ID gets the thread current ID. But I don't want current. I want exact. Okay, this is an ID, and what is it? It's a thread ID object. Okay, yeah, that's why. Okay, let's try to do this. An ID as U64. As U64. Okay, as U64. Let's check. And again, thread ID value. Yeah, the server clients push. Okay. Okay, so spawn returns not a thread. It returns the join handle. Interesting. Let's check what this join handle is. Okay, join handle, join thread. Okay, there is a thread inside, so we can use not the thread, but join handle. And here we can do this, but here we can do client thread ID as clients missing generic pop struct table T static T. Okay, something, and in our declaration is not right. Thread handle T. Very strange thing. Okay, handle. So this is a very handle join handle something. Thread join something. Okay, so let's use this. No. Okay. I don't know. Let's get back to idea of storing threads. But here we will just use client server clients push client thread. Okay, let's check again. Okay, thread value, thread is a method again. Okay, thread found end, so I need to unwrap it. No, I don't have an thread, so no, it's a double. Oops. Okay, so what we are trying to do here, we are pushing client to the thread, and client thread to our storage for client and server clients. We are getting through each client, but so expected check. Okay, so because this is client's vector, okay, so can we client's push expected thread found? Okay, let's unwrap it. No, we can't unwrap this result. Okay, well, let's go back to documentation and check. Okay, so reference both shared and mutable. Okay, reference and how we can, yeah, so ref and revenue partner for those familiar with the pointer. So we need to okay, so we have pointers here. Okay, let's pointers. Okay, primitive type. So okay, like in C. Yeah. Okay. So client ID, green, and stable thread ID. Okay. And again, cannot be formatted. What this red type thread? Okay, thread structs. What do we have here? Thread is what? Compact. Compact automatically makes the handle token available and this not already. Oh, it's not what we are interested in. ID is just okay. Name. Yeah, macros in Rust kind of meta programming. So it's the way how your program can override itself or change itself during the compilation. Okay. So I wanna see what the name options optional string. So it is none. Name is none. Name some. Okay. So it returns examples. Information name this naming thread name couple of. I don't like it. I don't like it right now. Sorry. So spawn is none. So now Name, we're not using named function, named thread, so we are using them. So we need to take a look on a thread ID. Create implementation. Okay. So functions. Park scoop. Oh, it's a thread now. We need to continue with struct thread ID, and ID is clone from format. Okay, so hasher, hash slice, implementation equal, not equal. So yeah, but we need to format self. So there is a way, but why it's so it's experimental, but why? Okay. Okay. We just want to. So what we are trying to do, we are trying to get the list how much clients, so for each, a list of connected clients right now. Okay. Let's just then return A. No. We can do this. Okay. So option string can be formatted. One string. Okay. Can be different. Option. Okay. So it could be dereferenced. Let's check once again. Name. Name. Option. Some, none. Okay, is some. Methods. Take. Unwrap. Returns contain some. Okay, yeah, got it now. So option name unwrap. Different doesn't have a size known at compile time. Very sad. Okay, I'm stuck with the quite useless thing. Okay, let's just think about this like this. Thread can be thread, which cannot move out of the shared reference. Okay, so this is not a thread safety, I suppose, right now. Okay, server clients moved due to the implicit call to the iterator in previous iteration of the loop. Okay, let's check how can we go through the items of vector once again without changing the vector. So as just cleared it up, okay, vector from with capacity slicing. We don't want to slice, we want to iterate. Do we have the possibility to iterate without? No, we have insert, cleared it up as slice, append, remove, truncate. Sorry. While that's on top, stack pop. Okay. Assert for. Oh, okay. It looks like we need to use this as a reference for iteration and do not change. Okay, so still have some issues, but let's help consider push client can borrow as mutable server clients push. Let mute. Okay, let mute server. Okay, if prefix. Okay. Installation clients 27. Node of thread will queue because there's a thread which does not implement. Okay. And here we want to use the reference. Something wrong. Vector named lifetime parameter. Okay, not like this. Okay. So I'm trying to follow the suggestion here to declare that it's type, but it's okay. I'm afraid we're a little bit stuck just because we don't use the whole details of subtopped here while still borrowed. Okay, this means that we are not thread safety here. And the idea to have the global structure to store everything is ruined. Interesting. Can we? No, we can create variables out of scope, out of function. So we need to search for another way to start this. Okay, thread safe. Let's get back to the thread. Okay, thread local structs functions. Let's see what functions we have in the thread. Available parallelism, minimum estimating, current, panicking, part. Media threads, thread local. Okay, let's think. Let's check the thread locals. No, it's on that one article. Declare a new thread local storage key. The type of thread local key. Okay, let's check what the thread local key is. Okay. Thread local. Static. Spell move full width set equal. Okay. Okay, we have 10 minutes left. It's obvious right now that we will not finish our application, but I think it was not bad. We are moved forward in understanding of what's going on with the Rust, with the basic types, and we can use the use it for creating something. So it's good start, but we really need to learn about the let's say static. Server. Okay. So yeah, unfortunately, compile to pref fiber. Okay, we have something to work with. There is ref cell. Static servers. Okay, we also need to close this. So it's equal to ref cell. Well, let's just try to use this type instead of creating a structure. Static. And yeah, this will be this thread. This is yep. Okay, vector of thread and equal to empty vector. Okay, so this couldn't be used right now, so we can use here colline's global so this we created the clients thread local. Well, let's try to call lines push for and clients. Reference, yeah, local key is not an iterator. Of course, we need to do clients, obtain the ref cell. Um, okay, I suggest to stop right now and continue at home. At least I will continue at home, and later I will publish the final result of working simple TCP chat. What next? Um, Next, I don't know what. We will, of course, do more coding, and I think we will continue to get deeper into the Rust language because it seems quite interesting. Uh, and well, it's always good to have compilable compilation compiled language in your stack because if you will need something very fast and very rapid, dynamic and I'm tired, sorry. Um, Interpreted languages will not be the case because they're much, much slower than compiled ones. Um, okay, thank you for being here and coding with me. See you soon on our next events. Bye.